All right, 7.4, the last part. We are just going to do graphing logarithmic functions today. And then, okay, so exponentials and logs are inverses. So these are inverses of each other. And for exponentials, we already know that domain is going to be all real numbers, and the range is going to be y's are greater than k. In this case, 2 to the x, it doesn't have any, there's no friends, so it's going to be greater than 0. So when I graph this, again, we can graph -1, 0, and 1. 0 and 1 are the key ones, but 2 to the -1 power, I'm going to flip that and get 1/2. 2 to the 0, anything to the 0 power is 1, and 2 to the first is 2. Okay, so when I graph that, I have -1, 1/2, 0, 1, 1, 2. All right, so I get this line. Okay. All right, and remember, inverses reflect on the y equals x-axis. Okay. And so with inverses, the domain and range switch. So now our range is going to be, for log base 2 of x, our range is going to be all real numbers. And domain is going to be, it's not going to be y because domain is x, but x is going to be greater than h. And in this case, we don't have an h, but don't worry, it will come back. It's going to be x is greater than 0. And then without actually graphing it, we're going to graph it, but it should look like this, where x is going to be greater than 0, so our asymptote is the y-axis. This is going to get really, really close to the y-axis and then go this way. Okay, so that's without actually graphing it, that's what it's going to look like. All right, so now we have an asymptote for logs at this, and eventually that's going to be the x equals h asymptote. Okay, so let's actually graph one. All right, so we're going to do graphing log base 3 of x. And so let's see. Let's try to plug in some numbers. What numbers do you want to choose? Good, 0 is a good one. So let's try that. Log base 3 of 0. Yeah, we can't do that, and we actually can't take log of a 0. So if you try log base 10 of 0, you'll get a domain error. What's another number to try? 1. That worked for the inverse, the exponential, so let's try it. Log base 3 of 1. I don't have any inverses there. I can't simplify it, so I have no idea what this is. All right, so 0 and 1 won't work. Let's see, let's try something else. What would be a good one to use? Let's try 3, and specifically 3 to the first. So if I have log base, hold on. If I have log base 3, and then my x value is 3 to the first, okay, now I have the inverse. So log base 3 of 3 is the inverse, so this just equals 1. So I have my first good point. 3 to the first equals 3, so I have 3 comma 1. Right? What's another good value to use? If you said 3 squared, that's a great one. So we have log base 3, and our x is going to be 3 squared. And what's nice about that is that has an inverse. So log base 3 of 3 is an inverse. So on the right side it equals 2. On the left side, 3 squared is equal to 9. All right, so what are some other good ones? How about 3 to the 0 power? So that's going to be log base 3, and then my x is going to be 3 to the 0. So go ahead and try, what do you get? Log base 3 of 3 is an inverse, so on the right side is equals 0, and 3 to the 0 power is equal to 1. Right. We could also do one more, and then we'll actually graph it, I promise. All right, if we have 3 to the negative 1, that's our x value. So our function is log base 3, and our x value is going to be 3 to the negative 1. So log base 3 of 3 is an inverse. So on this side I get negative 1, and 3 to the negative 1 is going to be 1/3. All right, so now we have some points to use. We have, I'll rewrite them up here. We have 3, comma 1, 3 squared, so that would be 9 and positive 2. 3 to the 0 is 1, and then y would be equal to 0. And then we have 1/3 and negative 1. So if we had log base 3, we want to use 3 to some power. If we had log base 4, what base would we use for the x? You said 4, good job. All right, so back to this one. Let's graph it. Let's see, we have 3, comma 1. Kind of, 3, comma 1. 9 and positive 2, so maybe right about there. We have 1, comma 0. Okay. 1/3 would be negative 1. Okay, so it gets really, really close to the asymptote. So here's our asymptote at the y-axis. That's x equals 0. So our asymptote is at x equals 0. So our graph is going to get really, really close to it, but not touch it. So it's going to go like this. Okay, so that is our first one. So our domain is going to be x is greater than 0. Eventually that's going to be h. And then now our range is all real numbers. Since we have negative 1, we have 0, we have 2, we have 1, so we can, for our range, we can get all the positive numbers, all the negative numbers, and 0, right? And then our asymptote is the y-axis, so it gets super, super close to that, but never actually reaches it. Okay, so if you have any questions, write them down, and I'll answer them. Example 2. So I'll rewrite this. We have y equals log base 1/2 of x. And then what we want is we want to find out some good y values. Okay. All right, so if you know the good x values, go ahead and plug them in all by your lonesome. So hopefully you've got things like 1/2 to the 0 power, 1/2 to the first power, 1/2 to maybe the negative 1 power, things like that. Right? So when I plug in my x, so log base, and x is going to be equal to 1/2 to the 0 power. Okay, you'll notice this is an inverse, so log base 1/2 of 1/2 is an inverse, so on the right side it equals 0. On the left side, anything to 0 power is equal to 1, so my first point is 1, comma 0. If you can go ahead and get the rest, pause it, get the rest, and then check back with me later. The next one, we're going to have log base 1/2 of, and my x value is 1/2 to the first power. So right here is the inverse. So that on the left side, on the right side equals 1. On the left side, 1/2 to the first power is 1/2. My next point is going to be log base 1/2 of 1/2 to the negative 1 power. So right here is the inverse. And so this right side is equal to negative 1. 1/2 to the negative 1 power. Well, that's the same thing as 1 to the negative 1 over 2 to the negative 1. So we're going to flip-flop that and get 2 over 1. Okay, so now we have our points to graph. So we're going to have 1, comma 0, 1/2, comma 1, and our x value of 2 and negative 1. Okay, so it's still going to our asymptote at x equals 0. It's still going there, but now it's going backwards because of the fraction. So it's getting super close to the asymptote, going through our points and going out that way. So it looks a little different because of the 1/2. But our domain is going to still is x is greater than 0, and our range is all real numbers. Okay. The range for logarithms will always be all real numbers, and the domain is going to be whatever greater than h. Okay. Questions, write them down, ask me tomorrow. Okay. Here is a checkpoint of sorts. So if you can set up this all by yourself, you have the first part of the lesson. So please go ahead and do this all by yourself and then check back with me later. Okay. Okay, hopefully you set up something like this, and hopefully you're just checking. But please set that up so it transfers to long-term memory. In the short term, you probably don't have to do this, but please set it up just like this. So all of those are inverses, so the left side becomes 0, 1, 2, and -1. The left side becomes 1, +4, +16, and 1/4. So if you have questions on that, ask me tomorrow, but hopefully you got those all by your lonesome. And when I graph it, I get 1, 0, 4, 1, 16, and 2. So I'll just put that right there. 1/4 and -1. Okay, so I get really, really close to the asymptote, but I don't cross it or touch it. And here's my asymptote right here, just the x = 0 line. So the domain is going to be x is greater than 0. Later that will become h, and our range is all real numbers. So if you did that all by yourself, that is awesome. Good job. Right? Next up we have an h. H is coming this way. All right, so before we do that, let's write this down. Okay. All right, so we have y equals log base b of x minus h. So again, h is the best friend, the BFF, so that's closer to the variable, and then k is on the outside. H is for horizontal shift, so h is the opposite direction, and it's horizontal. K is the same, and it's the vertical shift. All right, so the first thing we're going to do, so step 1 is we are going to first graph y equals log base b of x. So we're just going to ignore h and k, and we're just going to graph that. So we're just graphing this part. Okay. So that's the same as the chapter 6 graphs. It's the same for the exponential graphs too. So we're just graphing that part. And then step 2, we're going to shift the points using h and k, okay, and draw the new asymptote. Which is the boundary line. And that's going to be x = h, whatever h is. Okay. And then our domain is going to be x is greater than h, and our range is still all real numbers. Okay, so please have that down. All right, pause it, write it down if you need to, but those are the same steps that we're going to do. So if you can do all of the next problems by yourself, by all means, please pause it. Do the graphs all by your lonesome, and then check back and make sure you have what I have. But let's take a look at this one. All right, I only see one number. I don't see two numbers. So is that an H or a K? It is an H. Why is that an H? Tell yourself quickly. Why is that H? Okay, it's inside the parentheses. Good job. And is H -3 or +3? Okay, it's a +3. Why is that a +3? Because it's opposite. Great job. Okay, you guys are doing great. All right, so step one, we're just going to graph this part. Okay, so you can definitely do this because we just did this in the last one. But log base 4 of x. So pause it, find these points, graph the points, check back with me later. All right, and so for this one we picked 4 to the 0, 4 to the first, 4 to the -1. That's pretty much all you need. And then we could do log base 4 of 4 to the 0, log base 4 of 4 to the first, log base 4 of 4 to the -1. And then here are the inverses. Okay, so the right side, this equals 0, it equals 1, and it equals -1. On the left side, it equals 4 to the 0 is 1, 4 to the first is 4, and 4 to the -1 is -1/4. All right, so when I graph that, I get 1, 0, 4, +1, and -1, or 1/4 and -1. So there's my old graph. Okay, and then now I'm going to shift it. So H is 3. K, consequently, there is no K, so it's 0. So the only thing I'm going to do is shift all the points over 3. So I'll start with 1/4. So I'm going to shift it over 3 and land at 3 and 1/4. I'm going to shift 1 to over 4. And then 4 is going to shift to 7. I'm shifting every point. And then where is my new asymptote? Okay. So new asymptote is whatever h is. So my new asymptote is x equals 3. So my boundary line is going to be right there. So I want to draw that new boundary line, and then I'm going to connect the shifted points and get super, super close to the boundary line. And that's what you got. Okay, the blue line is that. All right, so our domain is going to be x is greater than 3, greater than our boundary line. And then our range is still all real numbers. Okay. All right. Questions, please write them down. Ask me in class tomorrow. All right. Our next one is, holy moly, it's got both numbers. This is excellent. All right. So what is h and what is k? What is h? What is k? H is -4. Why is it -4? Because it's opposite. Good job. Now what's k? And -2. Why is k -2? Well, it's the same. Okay, great job. All right, so what we want to first do, though, is we want to just get the points for this. Just that. So go ahead and do that. If you can do that all by your lonesome, you're doing great. You've got this lesson in the bag. All right. So 6 to the 0 should be good, 6 to the first, and 6 to the -1. So if you're still watching it and you didn't pause it, then please go back and go back, fill in them, see what you can get for x and y. So log base 6 of 6 to the 0, log base 6 of 6 to the first, and log base 6 of 6 to the -1. So here's the inverse, here's the inverse, here's the inverse. So we've got the right side equals 0, equals 1, and equals -1. Left side, this 6 to the 0 is 1, 6 to the first is 6, and 6 to the -1 is 1/6. So if you got these all by your lonesome, great job. And so we're going to graph them. So I've got 1, 0, 6, 1, and then we have 1, 6 in the middle between 1 and 0, and that's -1. Okay, so we get really, really close to the asymptote at the y-axis. Now we're going to shift it. So I'm going to take each point, and I'm going to go back 4 and down -2. So take 1, 6 and go back 4 All right, so I go back 4, somehow, back 4, and then down 2. Take this point at 1, 0, go back 4, and down 2. Take the point at 6, comma 1, go back 4 to 4, down 2. Okay, and my new asymptote is at x equals h, negative 4. Those should match. So here's my new asymptote at x equals negative 4. So my graph is going to get really, really close to that. So it's going to go like this, super close to it. Okay. And then the domain is going to be x is greater than negative 4. Okay, so h is negative 4, the asymptote's negative 4, the domain's negative 4, and then our range is all real numbers. Because we can have 0, we can have negative 1, or 1 and negative 1. So that covers all the bases. Okay, example 5, very similar. So if you can pause this and do this all by your lonesome, please do, and then check with me to see if you got the right answer. Okay, so hopefully you're not listening to this unless you got stuck somewhere along the way. But the more you can do by yourself, the better. So we are going to just graph that part, and then h is 5 and k is positive 4. Right? And then some good numbers to choose would be 3 to the 0, 3 to the first, and 3 to the negative 1. So when I plug those in for my x, I get that, and then the inverses, here's an inverse, here's an inverse, and here's an inverse. So this side equals 0, 1, and negative 1. The other side, 3 to the 0 is 1, 3 to the first is 3, and 3 to the negative 1 is 1/3. Okay, so when I go to graph those, I have 1, 0, 3, comma 1, and 1/3 and negative 1. So my unshifted graph gets really, really close to 0. Okay, now I want to take all those points and I want to shift them over 5 and up 4. So I'll start with this one. I'm going to go over 5 and up 4. Okay, over 5, 1, 2, 3, 4, 5, up 4. Over 5, and then up 4. All right, and then my asymptote is going to be at x equals 5. All right, so this one needs to be over. Just kidding. All right, so here's my new asymptote right here at x equals 5. And then I'm going to draw the graph really, really close to that. And that is my new graph. And then go ahead and write down the domain and range. Okay, hopefully you put x is greater than 5 and the range is all real numbers. Okay, and if you did that all by your lonesome, you have got the hang of this. Great job. All right, here's the first 4 guided practice, so pause them, write it down. And then here is the second set of guided practices from the book, and that's just 16 through 18. And be sure to include domain and range on all of them. And I will see you guys tomorrow.